Our next topic in physics is going to be acceleration, which is changing your speed. So anytime you're at like a stop sign or a stoplight and then you press on the gas pedal, you're accelerating or you're changing your speed. We've already talked about speed, and that's how fast something is moving or how much distance an object covers over a certain time. And we knew that speed was calculated by taking distance and dividing it by time. And we had this equation, speed is equal to distance over time. And we know some examples of speed, miles per hour, meters per second, kilometers per hour. All of those show a distance over a time. Velocity is very similar to speed. It tells you how fast an object is moving, but it also tells you direction. So 12 miles per hour would be a speed, but if you say you're going 12 miles per hour north, that would be a velocity because you include direction. The equation for velocity is exactly the same as speed because they are very similar to one another. Velocity is distance over time. The only difference is velocity includes this direction part, whether it's up or down or north or south. Velocity includes direction. Acceleration is the increasing or the decreasing of the speed of an object. Any object doing the following is accelerating. So if you're speeding up, you're accelerating. If you're slowing down, you're accelerating. Even if you're changing direction, you're accelerating. All of those things, if you're doing them, mean you are accelerating. And we've got all these terms here. Distance, we know we have a symbol of d, and we've got things like miles or meters, kilometers, centimeters. All of those things are a distance. We have time, which we use a t for. Seconds, minutes, hours, those are very common times. Speed or velocity, since they're very similar things, we use s for speed, v for velocity. Meters per second, miles per hour, kilometers per hour, those are all speeds. Our new one, acceleration here, acceleration starts with an A, and we're going to use an A to abbreviate acceleration. The unit we are going to use for acceleration in this unit is meters per second, which is the same as meters per second squared. This is the one we are going to use, meters per second squared. Anytime you see meters per second squared, that should tell you right away that is an acceleration. Meters per second, on the other hand, is a speed or velocity. And velocity is really the rate and change of distance, meaning how much distance do you cover divided by how much time it took you to go that distance. Right? So we would always get, when we did speed, distance over time. Acceleration, though, is the change not in the distance, but in the velocity. So acceleration is how much you change your velocity or how much you change your speed divided by the time it took you to change your speed. And so, since speed was distance over time, whenever you did a problem and you put your units in the problem, you would get meters over seconds, which meters per second is an example of a speed. Similarly, with acceleration, since velocity is on top, which is meters per second, and time in seconds is on bottom, that's what gives you meters per second, which we are going to show as meters per second squared. So those are the units for acceleration. Those are the only units we're going to use for acceleration. So anytime you see meters per second squared, that should tell you right away, oh, that's an acceleration. We have two equations for acceleration. This one right here, distance is equal to 0.5 or 1/2 times a times t squared. D stands for distance, A is for acceleration, and T is for time. So once again, if you know two of these things, you can figure out the third one by plugging them into this equation. Okay, that's the first equation we're going to use for acceleration. The second equation we're going to use for acceleration is VF is equal to VI plus A times T. VF stands for the final velocity, or the velocity at the end. VI stands for the initial velocity, so the velocity at the start, before you start accelerating. A represents acceleration, and T represents time. So if you have three of these things here and need to find the fourth one, you're going to plug it into this equation. Alright, so let's try a problem using these accelerations equations. So we have a cheetah is one of the fastest animals on land. A cheetah can go from standing to a speed of 26.8 meters per second or 60 miles per hour in 3 seconds. Okay, 3 seconds would be a time. If you're standing, that means you're not moving. We'll give you an initial speed of 0 meters per second. And the cheetah sped up to 26.8 meters per second. That would be our final velocity, what it sped up to. And our initial velocity, since it's standing, would be VI. Okay, so we have a problem here. And this is just showing the same thing. Here's what all of those things are. Anytime something says that it's standing or at rest, that should immediately tell you that the initial velocity is 0. Okay, so we're going to use these pieces, these 4 pieces, to plug them into an equation depending on what we're trying to find. So 1A is asking, what is the acceleration of the cheetah? Okay, well, if you look at this equation, this has acceleration in it, but we would need to know a distance and a time. We know a time, that's fine, but we don't know a distance. So we're going to have to use this equation. So here's where you would plug everything in. VF is 26.8 meters per second. VI is 0 meters per second. Plus A, which we don't know A, so I'm just going to write it as A, times T. I'm just going to put it in parentheses next to it, which means the same thing as multiplication. Now to solve for A here, what you need to do is first get rid of this 0. But if you subtract the 0 on both sides, it's not going to affect the other side. So what you're really going to be left with here, 26.8 meters per second is equal to A times 3 seconds. Okay, well, if we want to get A by itself, then we need to divide both sides by 3. So if I divide this side by 3 seconds, divide this side by 3 seconds, 3 seconds over here cancels, and you get A is equal to about 8.93. Okay, you might be wondering, okay, well, what are my units? Look in your work, meters per second over seconds, or meters per second squared. There's your acceleration. So the acceleration of the cheetah is 8.93 meters per second squared. And that means that every second, the cheetah is going to be going 8.93 meters per second faster than it was the second before. Okay, so here's the same setup. Meters per second. That's why we get meters per second squared. The second one, example 1b, is asking how far does the cheetah go? Okay, anything in this equation, velocity, acceleration, and time, none of these things are going to tell you how far. That would be a distance. This is the equation that has distance in it. So I'm going to list everything that I have. It's going to be helpful. You know that it was standing, so it has an initial velocity of 0. It sped up to 26.8. That's its final velocity. It accelerated at 8.93 for 3 seconds. We don't know how far it went, so we're going to use our other equation. And so here we go. Distance, what we're trying to find, is 0.5 times our acceleration of 8.93, which we got from the first part of the problem. And our time is 3 seconds. Now remember, exponents come before multiplication, so you need to square this 3 before you multiply it by the 8.93 or the 0.5. So 3 squared is 9. 9 times 8.93 times 0.5 will give you 40.15. And since our speed, or our velocity and our acceleration, all of them have a distance of meters in them, our distance is going to have a unit of meters. So anytime you're trying to find distance, you're using this equation that has d in it.